All right, we are going to talk today about two more types of reactions, single replacement and double replacement reactions. So we are going to start with single replacement. Single replacement is the situation where one element replaces another in a compound to form a new element and a new compound. So in this example, our general reaction here, A is the element that's coming in and replacing another one. So I like to show that A comes over here and kicks out B and takes its place. So B then got dumped and is all alone. And now A took its place and A is with C. Now, the only way that this is going to work is if A is a better metal than B. It has to be better to kick something else out. So metals can replace other metals because they're both cations and positive. And then nonmetals can only replace other nonmetals. They're both negative. But again, this has to be an upgrade in order for it to happen, or it won't happen. Remember that our analogy is if you're in a relationship with someone who's maybe kind of mean to you and smells bad and doesn't have a job and they're real lazy, you might not want to be with them. And so if you have the opportunity to get with someone who's nice and good looking and has a lot of money and they smell good, you might upgrade. So you might dump your old person and get with a new one. So that's kind of like what's going on here. It has to be an upgrade. So how do we know if it's an upgrade? Here we go. So the free element needs to be more active. So that's the word that we use for the reaction to occur. And we use this thing called the activity series that you have in your notes to determine whether an element is more active or not. Elements at the top are the most reactive or active. And so basically, I like to think of it as elements at the top of this list, such as lithium, potassium, barium. These are kind of the cool people that all the other elements want to be with. So if they have the opportunity to replace who they're with and replace it with something like lithium, potassium, barium, or something else at the top, they're going to go ahead and do it. On the other side of the activity series down here at the bottom, gold, platinum, silver, we've got these like not cool cave dudes. They probably don't smell very good. They don't have money. They don't do anything productive, so nobody wants to be with them. So if an element has an opportunity, let's give an example, to dump gold and get with lithium instead, that would be an upgrade, and so they would do that. The other possibility that we will have is the halogens can also trade places with each other. Now, group 17 of the periodic table is the halogens. If you look at your periodic table, you'll see that there's fluorine, chlorine, and then bromine, and then iodine. That is what we would call the activity series of the halogens. And so fluorine is kind of the cool guy. He's wearing his little sunglasses. Everybody wants to be with fluorine. He's cool. He's got a job. Iodine, on the other hand, is this grumpy caveman. Nobody really wants to be with him. So if an element has an opportunity to dump iodine and get with fluorine instead, that would be a good upgrade. So we have our activity series of metals here, and that is in your notes. And we have the activity series of the halogens, and that's included on your periodic table. Okay, so here are two examples of a single replacement reaction that we're just going to study for a minute and see why they work. So first up, we have lithium reacting with copper to sulfate. So lithium is over here all by itself. I like to think of these as a story. Copper is with sulfate. Well, if we look at copper and lithium on the activity series, so let's go back and erase some of this stuff that we have and find copper and lithium. Okay. Well, remember lithium was up here at the top. Lithium's like a cool guy element. Copper, on the other hand, is down here. Copper is nobody likes being with copper. He's angry and grumpy. So sulfate is going to dump copper and get with lithium instead. So Copper got dumped and it's now by itself, and lithium is with sulfate instead. Let's take a moment and make sure we understand, where did this 2 come from that I'm highlighting? Okay, lithium over here didn't have a 2. So we just need to remember our compound rules for how we write compounds. When we put lithium, which is Li plus 1, together with sulfate, which is SO4 minus 2, we still need to crisscross those charges. The 2 comes down here on the lithium. The 1 goes down, but it doesn't do anything. So that's where Li2SO4 comes from. Okay, what about the bottom example here? We have bromine all by itself coming along to sodium chloride. Well, bromine is a non-metal on the activity series of halogens. Remember, our halogen activity series is just like from the periodic table. So we have, let's highlight them. In this example, we have bromine and chlorine. Bromine and chlorine. Okay, who's better? Chlorine is better. So sodium is going to say to itself, if we make this into a story, hey, I'm with chlorine. Chlorine's cool. Bromine, on the other hand, is lower on the totem pole than chlorine. Why would I want to upgrade to bromine? That's not even an upgrade. So this reaction just doesn't even happen. Sodium says, I'm good. I'm going to stay with chlorine because it's more active, and bromine does not take chlorine's place. Okay, here's another example, and this is just kind of a picture for us to look at. So we have copper as our single element, and it is put into a solution of silver nitrate. So if we think about the substitution that might be happening here, copper is a metal, and it is going to try to kick out silver. So we're going to ask ourselves, is copper more active than silver? Can it do that? Let's look at copper and silver. Well, if we look from scratch here, copper is indeed higher than silver. Copper is an upgrade from silver. So if we go back and look here, copper is going to take silver's place. Copper, nitrate, those are now together, and silver got dumped. So this is the actual chemical reaction that we see taking place here. This is some copper mesh here at the top, and it was put into the silver nitrate solution. And so when the copper and the silver nitrate come together, the solution turns into copper nitrate, which is a blue solution. That's why we see that the solution is blue. And then silver is released as pure silver. And so all those little spiky solid things that we see forming there are actual silver. So that is a successful single replacement reaction. Okay, we're going to do a little practice here together. We are going to use the activity series to determine if the following single replacement reactions occur. If they do, we will write the equation and balance it. If the reaction does not occur, we will write the reactants, the yield sign, that's the arrow, and the words no reaction. So potassium and magnesium chloride. Here we go. So potassium by itself is just the element K. And now for this thing here, magnesium chloride, I'm going to think about those ions with their charges to put them together. Magnesium is Mg plus 2, chlorine is Cl minus 1. So crisscrossing, we have MgCl2. All right, potassium is a metal. It is going to try to replace another metal. So potassium and magnesium are my two metals here. I like to draw this little arrow as a visual for myself, that potassium is going to try to push out magnesium and take its place. But we need to check the activity series to see if it's able to do that. So I'm going to go back and look at potassium and magnesium in my activity series. So potassium is really cool, way up here at the top, very active. And magnesium is further down. So yes, potassium can kick out magnesium, so we are going to do that. Potassium will kick out the magnesium, and I like to go ahead and write the magnesium by itself now because in my mind, magnesium got dumped, and it's just easy to think of as my first product. And I'm going to now have potassium take its place. So instead of magnesium and chlorine together, my new product is going to be potassium and chlorine. If I write them with their ion symbols, with their charges, it's +1, -1. When you crisscross the ones and the ones, the formula is just KCl. So I now have my chemical reaction. The final step would be to balance this. I'm going to go ahead and erase my little orange markings here. To balance this, I look at all of my elements. I like to look at the metals first. Potassium has one on the left and one on the right. That's fine. Magnesium has one on the left and one on the right. Chlorine, however, is not balanced. Chlorine starts with 2, but it only ends with 1. So I'm going to need to put a coefficient of 2 in front of the KCl. There we go. And what did that just unbalance? My potassium is now 2 on the end. And so back here in the beginning, potassium needs a 2 in front of it as well. And I now have a balanced chemical equation. 2 potassiums, 1 magnesium, and 2 chlorines on both sides. Balanced equation done. All right, let's look at the next one. We have silver and copper 2 nitrate. So we will start by writing out the chemical symbols for what we start with. Silver is Ag and copper 2 nitrate. Let's think about this. Copper 2 is copper charge of 2. Nitrate is NO3 with a -1 charge. So crisscrossing the 1 does not do anything. The 2, when it comes down here, means nitrate needs to be in parentheses with the 2 on the outside. So my chemical formula is going to be Cu NO3 parentheses 2. All right. Arrow. So silver, I'm going to do this in orange again. Silver wants to kick out the other metal. Silver's the metal. It wants to replace copper. So we need to check our activity series and see, is silver able to do that? Silver is down here, and it's actually below copper. Silver cannot replace copper in a chemical because silver is lower on the activity series. So literally nothing would happen. If I put silver into a copper nitrate solution, nothing will happen. And so I literally write no reaction. I will sometimes write that as no RXN. That's our abbreviation for reaction. So that's it. If there's no reaction, you don't do anything. Finally, we have fluorine and lithium chloride. Okay, fluorine is F, and you'll recall that it's one of our diatomic elements. So I'm going to put a 2 down there. And lithium chloride is LiCl. And now we're going to ask ourselves, is this going to happen? Now this one is a little bit different. Fluorine, if you recall, is a non-metal, so it's going to try to kick out the other non-metal chlorine. So I'm going to think about my periodic table, group 17, fluorine, chlorine, bromine, iodine. Remember, that's group 17 of the periodic table. That is our activity series for fluorine, chlorine, bromine, and iodine. So is fluorine strong enough to kick out chlorine? Well, fluorine is here higher than chlorine. So yes, fluorine can kick out chlorine, and that would be an upgrade. So we're going to kick out chlorine. Let's write it by itself then. It got dumped. Chlorine then is going to be Cl2. And then lithium is now going to get with fluorine instead. Lithium has a charge of +1. Fluorine has a charge of -1. That means the formula is going to have no subscripts, LiF. All right, so that is going to be our chemical equation. And the final step will be to balance it. I see that the fluorine and the chlorine are both unbalanced. So I can start with either one. I'm going to start by looking at fluorine. And if you follow my little red pointer here, we see that fluorine starts with 2, but it ends with only 1. I need to put a 2 in front of that fluorine compound over here. So 2. Well, what did I just do? Now I see with my little red pointer that I ended with 2 lithiums. So I need to begin with 2 lithiums. That means over on this side at the front of the compound, I need a 2. And now let's look at chlorine. Chlorine has 2 on the left, 2 on the right. So that equation is good to go. All right, so that is a balanced single replacement reaction. It happened because fluorine was higher on the activity series than chlorine and was able to kick it out. All right. We have 2 more here that you can try on your own. I'd like you to pause the video and try them, and then unpause it and come back and check. Okay, here are our answers for those that you were to try on your own. Number 4 was a successful reaction. If we kind of think through what happens here, aluminum was successfully able to kick out gold because aluminum is higher than gold on the activity series. So gold got dumped and aluminum took its place in the reaction. All of my notes are on here. If you have any questions about the numbers, you should see that we crisscross the charges, and that's what led us to the compounds that are written there. All right, number 5, what was trying to happen? Iodine is the element that was by itself, and that's a halogen. Iodine tries to kick out bromine in that compound because if you think about it, those two, remember, are on that group 17 list: fluorine, chlorine, bromine, iodine. Well, iodine is like the worst of the worst. It's way down here at the bottom. It is not strong enough to kick out bromine in a compound. Bromine is going to hold strong with sodium and not give up its place. And so this is a no reaction. So the reasoning here is because iodine is lower on the activity series than bromine that it was trying to kick out. So this is a no reaction. All right, in class, we would do a demonstration here of magnesium and hydrochloric acid. Although we don't have the video here, we can go ahead and predict what would happen because it's going to follow all the same rules. So what are we going to start with? Again, magnesium and hydrochloric acid. So that's going to be Mg and HCl. Well, what's happening here in terms of who's trying to kick out who? This is the first time we're seeing it, but if you use your activity series, it'll make sense. Magnesium is going to try to kick out the hydrogen. The reason I know that is because magnesium is on the activity series with hydrogen. So if I erase some of my old notes here, I will identify here that magnesium and hydrogen are on the same list because they both form positive ions. So magnesium is strong enough to kick out hydrogen, so this will be a successful reaction. So we can go back and write what's going to happen. So if magnesium kicks out the hydrogen, hydrogen gets dumped. So H2 is going to be produced. Now, by the way, that's a gas. So in this actual reaction, you would see bubbles of gas form. And then magnesium and chlorine are going to get together. Now, that's not quite the right formula. So if we think about it, it's Mg plus 2 and Cl minus 1. We need to crisscross the charges. The 2 comes down on the Cl2, and that's got to go there. Okay, so we're going to kind of wrap this up and put them together. Magnesium plus hydrochloric acid forms hydrogen H2 gas and MgCl2. The elements that are not balanced here are H and Cl. We start with one H and one Cl, but over here on the product side, we have 2 H's and 2 Cl's. So we need 2 of those on the starting side. So I need to put a 2 in front of this HCl compound, and that will do the trick. All right. And that is a single replacement reaction. If you want to see this actually happen and you were absent in class, find my link on Google Classroom or on the unit HyperDoc to the Wakelet, and I will make sure that I put in the chemical reaction of magnesium and hydrochloric acid so you can actually see it happening and see those bubbles.